Hello guys, so today we will be doing a tutorial video on frictional loss in pipe. Before we begin, there are 4 factors that you need to know which will affect the friction loss in pipe. That is velocity, roughness, size, and length. For the first factor, that is velocity. Velocity is the movement of the fluid inside the pipe. Next is the roughness. In this experiment, we are using a 10 mm smooth pipe, 17 mm smooth pipe, and 17 mm rough pipe. The third factor is the size. That is the diameter of the pipe used. Last is the length. In this experiment, we are using a 1080 mm long pipe.
Next, we continue with objective. Okay, for this experiment, we want to determine the relationship between the Reynolds number, the frictional factor, and also the losses in pipe. Next, we also want to obtain the relationship between the heat loss due to fluid friction and also the velocity for flow of water through the bore pipe. Hi guys, okay, so next we move to the equipment description. So we start with control valve, flow meter, volumetric tank, drain valve. Once we pull out this valve, the water will come out from volumetric tank to sump tank. Next, there are 2 hoses, one for water in. The water will suck from the sump tank to the piping system, and another one is for water out. Water will come out from piping system and goes to volumetric tank. We use 3 type different bore pipe, which is 7 mm and 70 mm smooth bore pipe, and another one is 70 mm artificial rough pipe. Hose that connect piping system to the manometer. That one is H1, and this one is H2. Okay, and the last one is manometer. That's all from me. Thank you.
Next, we have to fix the tubings at these 10 smooth bore pipes. And then for the next, we open the valve, turn to left. But we have to observe the H1 and H2 at the manometer, which H1 equals to H2 at the water manometer. For the next part, we open the pump switch. Next, we have to control the valve to the speed 1. For next, we calculate the H1 and H2. We see a difference between the H1 and H2. So this is H1, so this is H2. So we have to observe is the hydraulic bench for the volumetric tank. We have to take the time taken. When it reaches 0, we start the time taken, and when it reaches 5 liters of the volumetric tank, we have to stop the time taken and record the time taken. After we record the time taken for the speed 1, we have to repeat it with speed 2 and speed 3 by opening the control valve and control it with a different height of the H1 and H2, which are initially at the same level. So, and then we have to repeat it with a 17 smooth pipe and then a 17 rough pipe. So for the overall experiment, the data has been taken for 3 sets.
So now I will talk about fluid friction and losses in pipe application in our real life. So in industry, such as chemical plants, there's a lot of pipe. So chemical engineer will determine the percentage of tear and wear of the pipe by determining the flow rate. Okay, for example, engineer will pump the water into the pipe. So the larger pipe will have a higher velocity due to it have less area for for the water to flow in compared to normal pipe. As you can see, this is the raster pipe, this is a normal pipe. So raster pipe will have high friction, F, high velocity, V, but in low efficiency. So determination of raster pipe is very important because the raster pipe will result in high cost in terms of electricity and time of the process. So this whole experiment is applied in all pipeline system to determine the flow rate, the condition of the pipe, that's all.
The experiment is conducted to measure the head loss in the pipe due to the friction between the fluid and the wall of the pipe. Different diameters give different flow rates. Therefore, in this experiment, we measure the friction factor of the pipe using the data taken. There are few precautions that we should consider to get a better result. First, make sure that there is no bubble in the manometer. Next, when connecting the tube, make sure there is a click sound to avoid leakage. And lastly, eyes should be perpendicular to the reading of the manometer to avoid parallax error.